Welcome to the Intermediate Robotics course from Botronix Labs. In this series, we'll build more advanced robots using the Raspberry Pi Pico W, wireless communication, object-oriented programming, and new sensors and actuators. Today, in Module 1, we're kicking off the Pico Tank project, a remotely controlled robot tank. We'll introduce DC gear motors, the hw-354 motor driver board, and show you how to use object-oriented programming in MicroPython to control your robot. By the end of this module, you'll be able to understand how DC motors and the hw-354 motor driver board work, connect and control DC motors using GPIO pins 2 through 5, apply object-oriented programming OP principles in MicroPython, and implement safe control logic with proper exception handling. For this project you'll need a Raspberry Pi Pico W, an hw-354 dual DC motor driver board, 2 geared DC motors with wheels, a 3.7V 18650 battery, a USB cable for programming. The 3D printed robot tank model featured in this project was designed by Quartz 3210 and is available on Thingiverse under the CC BY and CSA license. Please check the video description for the download link and remember to credit the original author if you share your build. Let's start with the basics. DC motors rotate when you apply voltage across their terminals. The direction depends on the polarity. The hw-354 uses H-bridge circuits to control the direction of each DC motor. An H-bridge is an arrangement of transistors that allows current to flow through the motor in either direction, enabling both forward and backward rotation. By setting the input pins, IN1/IN2 for motor A, IN3/IN4 for motor B, high or low, you control which transistors in the H-bridge are active, thus changing the direction or stopping the motor. If IN1 is high and IN2 is low, current flows one way and the motor spins forward. If IN1 is low and IN2 is high, current flows the other way and the motor spins backward. If both are low or both are high, the motor stops. ENA and ENB should be connected to VCC for full speed, or you can use PWM for speed control if you want. Here's how to connect your Pico W to the hw-354. IN1 to GP2, then 2 to GP3, then 3 to GP4, then 4 to GP5, then D to D common. VSYS to your battery's positive terminal. Before we dive into the code, let's talk about object-oriented programming, or OP. OP is a way of structuring your code so that related data and functions are grouped together into objects. This makes your code more modular, reusable, and easier to maintain, especially as your robotics projects get more complex. That's why, instead of putting all our code in one file, we'll create a separate file called robot_tank.py just for our robot tank class. This keeps our motor control logic organized and lets us reuse or expand it in future projects. Now, let's look at the code for the robot tank class in MicroPython. By using OOP and keeping this class in its own file, our code is cleaner, easier to test, and ready for more advanced features down the road. Let's test our robot. In your main.py, import the robot tank class and run this code. This script will move your tank forward, go backward, turn left, and turn right, then stop the motors safely even if you interrupt the program. We use GPIO pins as digital outputs to control the motor direction. OP in MicroPython makes our code modular and scalable. The try, finally block ensures the motors always stop, even if there's an error or you press Ctrl+C. In this module, we learned how motor drivers and DC motors operate, wired up your robot using GPIO 2 to 5, created and tested a reusable robot class with OP, and handled motor shutdown gracefully with Python exceptions. Great job! You've built the foundation for your BLE-controlled Pico Tank robot. In the next modules, we'll add wireless control, sensors, and more advanced features. If you enjoyed this lesson, don't forget to subscribe and stay tuned for more intermediate robotics projects from Botronix Labs.